Welcome to the full solutions to the practice questions from the second cross product video on the vector series. Okay, for the very first question here, we're given vectors A, B, and C, and we want to determine a few operations on them. For the very first operation here, we need to do what's in brackets first. That's order of operations. So we're going to do vector B cross vector C first. So that's going to be I, J, K. And for vector B, my components are negative 1, 2, and 3. And for vector C, they are 0, 1, and 0. I'm going to start with I. We will block off the top row and I column, and we will multiply 2 times 0 minus 1 times 3. We're going to do minus j, and we are going to block off j and the top row, and we are going to multiply negative 1 by 0 and subtract that by 0 times 3, and we're going to add k, or unit vector k multiplied by. To do this, we are going to cross out the top row and the k column, and it will be negative 1 times 1 or minus 2 times 0. We will get I, or unit vector I, 0 minus 3 minus j, unit vector j. We get 0 minus 0 plus unit vector k, negative 1 minus 0. And that will simplify to negative 3 here, minus j times 0, which is just 0, plus unit vector k times negative 1, meaning that our final vector will have an x component of negative 3, y component of 0, and a z component of negative 1. Now we want to get the dot product of this with vector A, so vector A dot B cross C, and that's going to equal to, for vector A, my components are 3, negative 1, and 4, and we're going to do a dot product with negative 3, 0, and negative 1. So now we are going to multiply the x components, y components, and z components and add them together. So this is 3 times negative 3 plus negative 1 times 0 plus 4 times negative 1. That's negative 9 plus 0 minus 4, which is negative 13. For part B of this question, we're asked to do this operation. We need to do what's in brackets first. Again, order of operations. So that's vector B minus vector C. So we will take the x, y, and z components of vector B and subtract them by the x, y, and z components of vector C. And when we do that, we will get negative 1. 2 minus 1 is 1, and 3 minus 0 is 3. We now want the cross product of A and B minus C. So we will set up our system here. We got I, J, and K. And we will do vector A, which has components 3, negative 1, and 4, and vector B minus C, which has components negative 1, 1, and 3. For I, we're going to block off this column in the top row, and we will have things equal to vector I multiplied by this times this, so negative 1 times 3 minus 4 times 1. For the j components, we are going to block off the j column, and we will get minus j, that's the second one, we use minus, and it'll be 3 times 3 minus 4 times -1. And for our last component, we are going to block off the k column, and we are going to have 3 times 1 minus -1 times -1. This simplifies to I. We got -3 minus 4 minus j. 3 times 3 is 9. -4 times -1 is +4. And we have k, and we have 3 minus -1 times -1 is 1. So our component for x is going to be -7. Our component for j is going to be -13. And our k component is going to equal to, or the z component is going to be 2. And I'll write it in this format as well. 13, that's -13 and +2. In the next question, we have a 30 Newton force that's applied to the end of 0.5 meter wrench that makes an angle of 60 degrees with the handle. And we want to determine the magnitude of the torque that's caused by this, and also the maximum possible magnitude that we can have from the torque. For part A, we got a 30 Newton force, and we have 0.5 meter at an angle of 60 degrees. This is 0.5 meters, and we're going to get a resultant vector which is perpendicular to both, and basically in terms of rotation, force crossed by thing will have this direction of rotation, but we're not asked for any of those. We are only asked for the magnitude of the torque, which is the magnitude of the cross product of force and displacement. This becomes the magnitude of the force vector multiplied by the magnitude of the displacement vector multiplied by the sine of the angle between them. Magnitude of the force is 30 newtons, the magnitude of the displacement is 0.5 meters, and the angle between the two is 60 degrees. If we multiply these together, 30 times 0.5 is 15, and sine of 60 is √3/2. So my final answer here can be just this, Newton meters, or I can write it as a rounded value, and if I do that, I will get 13.0 in 3 significant figures. Well, this is the answer to part A of the question, but for part B, we're asked what is the maximum possible torque that we can actually exert using these two values. So if we have our wrench over here, and we are trying to make a rotation, let's say the displacement here is 0.5, and the force that we're putting on it makes an angle of 60 degrees. So that would be this angle over here, 60. So if I were to draw that here, somebody is pushing right here, but the angle is 60 degrees. To exert the maximum force, we need to have the highest possible perpendicular component in this direction. So we want to take that 30 Newton going at an angle and apply it completely perpendicular, meaning that we're going to change angle theta from 60 to 90 degrees, and that will give us the highest possible ability to rotate. That's the conceptual way of looking at it, but mathematically, if we want to look at it, we know the magnitude of the torque is equal to the magnitude of the force times the magnitude of the displacement times sine of theta. We know the magnitude of force is what they've put in, that's 30 Newton. The displacement is 0.5, that's the distance away from the center of mass. But this angle over here, that can be changed. The person can put it at a 60 degrees, or they can put it at 90 or even 10 degrees. It's really their choice. And this angle is actually extremely important because if we look at a sine function, it starts and goes like this forever, and the maximum value that it can take is positive and -1. So the magnitude, the maximum size is only 1. And to achieve that, we need an angle of 90 degrees. So this, if it is done at 90 degrees, we'll have a value of 1. And that means we multiply everything here by 1 to get a maximum possible torque of 15 Newton meters. Now, let's look at a more challenging question, and this one is nice because it uses many different concepts and it also links dot products to cross products. So, given that vector A has a magnitude of 3, vector B has a magnitude of 5, and that when we take the cross products of vectors A and B, we get components 1, -3, and -4 for the x, y, and z. We want to determine all possible values of the dot product of vectors A and B. There are many different ways of doing this question. I am going to use one where we will get an exact solution. And before we start, I will write A cross B in its component form. And one way to start this question is to write all the equations that we have. One is that the magnitude of the cross products of vectors A and B is equal to the magnitude of A times magnitude of B times the sine of theta, and that the dot products between A and B is equal to the magnitude of A times magnitude of B times cosine of theta. From these two equations, you can see that the magnitude of the cross product of A and B, we can find it through the components here. So we'll do that first. We have this component, we have this component. We don't have sine theta. We also, in the dot product, we have the two components. So if we can find a relationship between sine theta and cosine of theta, we can find this. Or if we find the angle, we can do it as well. Okay, let's start by finding the magnitude of the cross product of vectors A and B. That is the root of the x component squared plus the y component squared plus the z component squared. And that will end up being 1 plus 9 plus 16, which is the root of 26. Once we have this, we can plug it all back into here. We know that this is root 26, and this is going to equal to the magnitude of A, which is 3, magnitude of B, which is 5, times sine theta, and we can rearrange for sine theta to get root 26. We're going to divide both sides by 3 and 5 to get 15 as our denominator. On the right-hand side here, we know for the dot product, we have the magnitude of A is 3, magnitude of B is 5. We don't have cosine of theta, but there is a relationship between sine theta and cosine of theta, and that is using our trig knowledge, sine squared theta plus cos squared theta is equal to 1. So I can rearrange for cosine squared of theta by subtracting sine squared theta from both sides. So I will get cos squared theta is equal to 1 minus sine squared theta. and I will take the square root of both sides, and I will get plus or minus 1 minus sine squared theta here. Now I can use this information here and plug it into here. So I get cosine of theta is equal to plus or minus 1 minus sine theta is root 26 over 15, and I need to square that because it's sine squared. When I do this, I get plus or minus 1 minus 26 over 225, and that ends up being the root of plus or minus root of 199 over 225, and this can be simplified as root 199 over root 225 plus or minus, and that's same as root 199 over 15 because a root of 225 is equal to 15. Okay, now I have everything that I need for this section over here. So I have A dot B is equal to the magnitude of A, which is 3, magnitude of B, which is 5, times cosine of theta, which is either positive 199 over 15, or it's going to be 3 times 5 times negative. So I'm going to put the negative here, root 199 over 15. Well, 3 times 5 is 15 times 1 root 199 over 15, or negative 15 times root 199 over 15. 15's cross out here, so my final answer is root 199 or negative root 199. And these are my two possible solutions, depending on whether the angle is acute or obtuse for the dot product. I hope that this video was helpful for giving you some more challenging question with regards to cross products, and thank you for watching.